Okay, so on this 4748 preview, it says let the vertical height h equal 480 feet. That's 480 is this distance here on the worksheet. Okay, so otherwise you can't solve it, and these are right angles. So the vertical height is 480 feet. So that's listed there. We don't round and put a final answer. Okay. So that's just two problems due next time. Oh, there's two. Yeah. I made it due for Thursday since we're going to give a take-home test. This is, you already learned how to do this. You did a problem like this for the last one. And this is what we're doing now. Okay. So solving a right triangle is finding it means you're going to find the missing lengths of its sides and the measurements of its angles. And they're labeling the angles capital A, B, and C, and then the sides opposite to angle A would be small a. The length of the side opposite angle C would be small c, which is the hypotenuse. Okay? And when we're going to use sine, cosine, and tangent functions rather than their reciprocals. Why do we want to use sine, cosine, and tangent? Because that's what our calculator does. Okay, so this was the example we did last time. Let's see, 62. Yeah. Okay, so a refresher. You know, I tried to sneak this in at the end, so I may have lost you guys. So you're gonna draw a right triangle and label the angles A, B, and C is the right triangle, and then small a is opposite capital A. Draw it out, and then it says A is 62.7, so I've labeled that degrees. Small a, that was capital A, so that's angle A. Small a is 8.4. Solve the right triangle, rounding lengths to 2 decimal places. So, well, so what's, this is one of the preview things you're supposed to know, but the interior angles of a triangle add up to 180 degrees. Let's see, do I have split table? You guys remember that? Okay. The interior, the angles A, B, and C add up to 180 degrees because they're the interior angles of the triangle. And so, therefore, since C is 90 degrees, that means A plus B must equal 90 degrees. So you can find angle B. So whenever you're given one angle on one of these right triangles, you can find the other one, and you're going to use the fact that they add up to 90. Okay, and then you need to find the missing sides. Well, here's side B was missing, so I decided, well, what could I'd like to get it's best to get B in the numerator. So I said, well, if I take tangent at 27.3, that's opposite over adjacent. Tangent at 27.3 degrees is B over 8.4. Multiply through by 8.4, and then I just did that in my calculator. B was 8.4 times tangent at 27.3 degrees. Make sure your mode's in degrees. And that's how I found B. And then You could use the Pythagorean theorem to find C, but I think it's going to be easier to use one of the functions. So using sine, cosine, and tangent, there was no way to get C, the small c over here, the hypotenuse, in the numerator, so I just got it. I took the sine, sine, it doesn't matter which one you pick, but you may as well pick something where you were originally given. So sine of 62.7 degrees equals opposite over hypotenuse is 8.4 over small c. And then I made that into a fraction, and I kind of skipped some steps, but you could cross multiply. You get C times sine of 62.7 degrees equals 8.4, and then you divide by sine 62.7. And that's what you get. Or you can realize that you can just switch the C and the sine. Just switch these guys, and that's kind of what I did. Maybe some shortcuts. So I cross multiply. They're just, when you cross multiply, then when you divide, it's the same as switching these two. So you could switch. You could switch these terms, or you could switch these terms around. Okay, so then I typed that in the calculator correctly and got the answer. All right, any questions? This section's actually a little easier than the previous one, okay? But just got to get used to using sine, cosine, tangent to find things. So here's another example. Let's go to the Eiffel Tower. I should have a picture of the Eiffel Tower. All right. So there's a picture in the slideshow of the Eiffel Tower. Let's see that. Okay. All right. Okay. So there's a picture. We're going to draw our own picture on the paper. One skill you should be able to do is learn to draw pictures and to solve your problems. You're not always going to have the picture given to you. So a point on the ground, on level ground, 80 feet. Level ground, okay, 80 feet from the base of the Eiffel Tower.
Quick question for you.
Yeah.
Is there a place where we can access the notes you're using? Because the ones on Northeast or D2L are compressed. Like they're. I mean, I can use a separate sheet of paper. I was just curious. You.
Let's see. I might have the ones on D2L are compressed too. Well, if you want me to, I can put these in here. We'll see if I have them. And let's see, 20 test. No.
Oh, you're right.
Test 2 material. Did you find it?
Well, he gave me a brilliant idea where I can just go into Word and enter spaces. So I think I'm going to do that real quick.
Oh, you can, or...
Yeah, that was good.
It's for 8 class, no. What does this look like? This is the compressed version. Right? No? That's the ones I'm using. Okay.
Sorry about that.
Well, but these notes, I don't have these posted. I have the old ones. I know Strogan has the old ones, right? Yeah, if it's a Word document, you can go in and add spaces.
Yeah, that's a good idea.
Oh, that came up. Anyway, does you guys need that then? No?
No.
Sorry about that. I have it on my disk, but I never got it over to D2L. Or Toby, do you like this? You guys like the, gives you room to write? Notes, yeah. All right, so here's on a point on level ground to the base of the Eiffel Tower. So this is the Eiffel Tower. Is 80 feet. This point is 80 feet from the base of the level of the Eiffel Tower, and the angle of elevation. So you need to know the angle of elevation. That's the angle from the horizon up. So this is the angle of elevation, 85.4 degrees. Approximate the height of the Eiffel Tower to the nearest foot. So this is going to be our x. Okay. So we don't know c. We don't know the hypotenuse, but we don't need that. So what trig function can we use? The tangent. Tangent is opposite over adjacent. That way we don't have to find the hypotenuse. Tangent of 85.4 degrees is opposite over adjacent is x over 80. So we're going to multiply through by 80. So x is 80 times tangent of 85.4 degrees. So take your calculator and you're going to make sure you're in degree mode. Because you get the wrong answers. Then you get all, you guys are in an upper level math class, so you put it in the wrong degree. The wrong mode, I don't think, there it's in degrees. Okay. So I think you should be able to switch back and forth between mode and radians. 80 times tangent of 85.4. And if we had it in radians, we get a ridiculous answer. What? How tall do you think the Eiffel Tower?
It would have been 52.
What?
I tried it like that, then I was like, that's not correct, then I changed it back.
You tried what? Did you do a radian?
Radians, and then I tried, I was like, that's not correct, so.
Yeah, radians.
Then I put in degrees, and then I just.
Gives you a whole, so what happens if we're in the wrong mode?
It's 52 feet.
You get 52 feet.
Roughly, correct.
Yeah. Second, enter. Yeah, that's what you get. So you guys need to be more careful about that. So make sure you're in the right degree mode. We got to be in degree mode. Okay, so the answer is not 52. It's to the nearest foot. So it's 994 feet. And so we drew a right triangle. We labeled all the given sides and or angles. That page number is wrong probably for the book because. Now, I sent you guys a message about the book. Are you guys all able to see it through the E Pearson app, the Pearson text app? Did they fix that? I asked them to.
I don't know, I use it for MathLab.
Mine works just fine.
Yours work fine? The Pearson text app? Well, you can see the book through My MathLab no matter what, as long as you have a good access code. But the if you have an electronic device, it's probably not a phone. Phone's kind of small to read the book in.
I still can't access it.
You can't. Well, I told her she's working on it, but I didn't know if anybody else needed it, or the book is really good. The eText app looks like this now. It says eText with these like bookmark things on it. And when you go into it, you're supposed to be able to put in your username and password from MathLab and see your book. And that way you could even, there it is. So I want the pre-calculus book, so I click on that. And then, say you're going on a trip and you want to be able to use a tablet or an iPad to see your book. Like, if you're going to the beach, you know.
Yeah, just pull out the pre-calculus code.
Yeah. I mean, you're gonna at Myrtle Beach. You're gonna. Oh yeah.
Right. Now you're just making me excited even more for my trip.
Anyway, no, but you can even download the book into here so that you don't have to be connected to the internet to see it. You can download some chapters. Anyway. But I'm trying to find out if anybody else is having issues with it, because, I'm requesting that they fix it, so. And I actually sent them the whole class list, and I don't think they're gonna be happy with that.
Probably not.
Because I don't know, I mean, yours is working, Ryan, okay.
I just bought the physical copy, it's easier that way.
The physical copy, yeah. See, if you're at the beach, you can have your physical book with you.
Yeah, that's what I want to take with me to the beach.
Yeah, that's the one thing, if you were going to bring one thing.
I gotta pick the math book up or a cooler full of beer
Oh, my gosh.
that I'm
Oh,
not even allowed to take to the beach.
okay. All right, the next example, so these are not as bad, but this next example, so you have to use inverse sine functions for it. So let's draw the picture. There's a guy wire, it's 13.8 yards long, it is attached from the ground to a pole 6.7 yards above the ground. So, all right, so we've got a guy wire is 13 point, no, that's not the wire. Okay. A guy wire is a wire that goes between something else and the ground. That's a slant. It's attached from the ground to a pole 6.7 yards above the ground. So this is a pole, this is 6.7 yards. And we've got, this is our guy wire. This is 13.8 yards. Find the nearest tenth that the wire makes with the ground. They could have said find the angle of elevation, but they just said, okay, so that's theta. So we need to find an angle. So what function is this? Opposite over hypotenuse, that's sine. So sine theta equals 6.7 over 13.8. And now that means that theta equals inverse sine of 6.7 over 13.8. And we want degrees, so make sure your mode is in degrees. Then that's it. So if we want an angle, then we know that this is a steps. This is your work. You draw the picture, you write this, and then you write this, and then you put it in your calculator. Second inverse sine of 6.7. I think I switched it back to, yeah. 6.7 divided by 13.8. And to the nearest tenth of a degree, so 29.0. There's our angle. Okay, and then they wrote it out a sentence. The wire makes an angle approximately 29 degrees with the ground. All right, now we're going to cover bearings. Anybody done bearings before? All right. So, next page. All right, so this is explaining it, and we're going to fill in the blanks over here. So, a bearing is a term that specifies the location of one point relative to another. Applications include navigation and surveying problems. So the bearing from point O to P is the acute angle. That's in how many degrees?
90.
Right.
Measured in degrees between ray OP and A, and we have a picture. Oh, that's not for that. Okay. Well, I'll bet we have a picture. And OP in a north-south line. So the bearing from point O to P is the acute angle measured in degrees between ray OP and a north-south line. The north-south and east-west line intersect at right angles. There are three parts to each bearing: a letter, north or south, and the measure of an acute angle. And a letter, east or west. Okay, so I'll draw a picture in a second. So if the acute angle is, let's see, do we have some pictures up here? So each bearing has three parts: a letter, north or south, a measured acute angle, and a letter, east or west. So the acute angle is measured from the north-south, from the north side of the north-south line. We write the N first. So we got a 40-degree angle here. Here's OP, and it's 40 degrees from the north-south line, and it's closest to the north. So that's why we write the N first. Then we write the measure of the acute angle. If the acute angle is measured on the east side, then we write E last.
Okay, so it's closest to north. So we write this angle here as north 40 degrees east. So, I wrote 30 on notes. Let's see. If the acute angle is measured, so we had a picture like this. We had a 40-degree angle. North, south, east, west. So we're closest to the north, so we write north. We write the acute angle. And we're on the east side of north, so we write east. That's that angle right there. So we write the N first if it's on the north side, and then if it's up here, if it's down here, we write S first. Next we write the measure, the acute angle, and then if the acute angle is measured on the east side of the north-south line, we write east-west. Draw a sketch. So this is 40 degrees north, 40 degrees east, right here. If the acute angle is measured on the west side of the north-south line, we write west-west. So we could draw another picture to show an angle, say, at 30 degrees from the north-south line. This angle would be written as north 30 degrees west.
Would north 45 degrees east be interchangeable with east 45 degrees north?
No, we always write north or south first.
Oh, gotcha.
Okay? So we're going to write north or south first. So do you want me to, so I can draw, okay, and then we got more pictures to draw. So we write north or south first. Then we write the measure of the acute angle, and then we write east or west, E or W. Okay? And then we got some more slides on this. So here's an example. I didn't do the 65 degrees. But here's an example of north 65 degrees west. So the angle was on the north side of the north-south line. So we write north first. We write the acute angle of between the north-south line and that angle. We're not writing against the x-axis anymore. It's bearing. And then we write, since it's on the west side, we write W. Okay, so here's how we write it with south. Here's an example of 70 degrees. All right. If the acute angle is measured from the south side of the north-south line, then we write S first. We write S first. Then the measure of the acute angle is written next. And then if the acute angle is measured on the east side of the north-south line, we write east, left. Here's a sketch. Let's see, fit it in over here. So we can use the ones they've done on the slideshow. They're using 70 degrees there. Okay. Start it here. So this is south, north, east, west. They got 70 degrees. So because it's on, this is the south side, we do south 70 degrees, and then because it's on toward the east, we do east. If it was on this side, we do west. And then if the acute angle is measured on the west side of the north-south line, we write west, last.
So another example. So they did, they didn't do an example, I'll just do one. Okay. So we want to do, we can pick any angle. So if we do 35 degrees here, this angle would be written as south 35 degrees west. Okay, but the important thing is to realize that your angles are always with respect to the north-south line. Okay. So now we're going to use the figure, and my figure's on the next page. We're going to use the figure to find the bearing from O to D. Oh, I have to label some letters too. Okay. Let's bring up the picture on the slideshow. There it is. They've got these. I have to label the letters on it. On your notes, it doesn't have the letters. This is A. This is B. This is C, and this is D. So from, and what's O? What's O? O is the origin. So if you want to go from O to letter D, that's here, but from, this is the angle from O to D, but we're using bearings now. So we have to, we're not going to be writing this one. It's going to be right here, the 25 degrees. So it's on the south, it's this one. It's on the S. We write 25 degrees. And it's toward the east, so we write east. From O to C, well, we're going to use this one now. Here's C. We are still on the south end, and it's 15 degrees, and it's to the west. And that is bearing. So there's there's just an extra credit question on the test on that. It's really, but okay. The simple harmonic motion. So I'm going to go ahead and move the slide. Okay, so here's simple harmonic motion. All right. Remember that y equals a cosine of bx minus c plus d. And the period is 2 pi over b. So an object that moves on a coordinate axis is in simple harmonic
motion. Like this could be a spring. If its distance from the origin, D, at time t is given by either D equals A cosine omega t, or D equals A sine omega t. We're just using it looks like a W, it's an omega, small omega. I brought that up, wrote that down to remind you, this is for section 4.6. The amplitude is the absolute value of, so we use small a there, so it's the absolute value of small a. It's the maximum displacement of the object from its rest position. The period of the motion is 2 pi. Since we're using, instead of b, we're using omega, it's 2 pi over omega, where omega is greater than 0. So d equals a cosine of omega t is used if the object is at its greatest distance from the rest position at the origin, at t equals 0. And we use d equals a sine omega t if it's at its rest position at the if its greatest distance from the rest position is at the if it's so cosine, remember cosine looks like this. That's cosine. So if its greatest distance is at the origin, away from rest position, we use cosine. Sine looks like this. So if the object is at its rest position at the origin, at t equals 0. So this will be 0. Sine is at its rest position at the origin. Okay? So that's why when we use sine and when we use cosine, and so that's exactly what the slide says. So we're going to do an example. Okay, so we have a ball and a spring and it's pulled 6 inches below its rest position. So we got a spring and it's pulled down to 6 inches below its rest position. And then released. The period for the motion is 4 seconds. Write the equation for the ball's simple harmonic motion. You're going to pull it down on the spring and let go of it. It's going to go down. It's a harmonic. It is a simple harmonic motion. It can be modeled because we pulled it down to 6 inches. That's the cosine function. And when the ball is released, t is 0, and the distance the ball is from the rest position is 6 inches down. D is negative. Because it is down. Remember D, I'm talking about this. let's write this equation back up here. Y equals A cosine of bx minus c plus d. And the period is 2 pi over b. So we're saying our d is negative because we pulled it down. Since the greatest distance from rest position occurs at t equals 0, we use the cosine function of the form. And there's no phase shift, so we won't have the c. So it's going to be, but d equals a cosine omega t. We're using omega instead of b. Okay, the absolute value of A is the maximum displacement, which is 6, negative 6. The period is 2 pi over omega. And they told us the period was 4. So we're going to use that to find omega. So you're given the period was 4, we're going to find omega. We can cross multiply, or you get 4 omega equals 2 pi, and then divide by 4. Omega is pi over 2. Do you all follow that? This was the period, 4. 2 pi over omega is the period. So I cross multiplied, got 4 omega equals 2 pi, divided by 4. Omega is pi over 2. So we found omega, we found A, and so our equation is, D is negative. Our equation is, D. We're talking about the small d, sorry. We're actually not using that either. This should have been the small d, the distance. Distance is negative. So the equation is d equals negative 6 cosine omega is pi over 2 times t. Okay, so that's our equation. We were given the period. We used 2 pi over omega to find omega. We were given the maximum displacement. We use that to find A. Frequency. Okay, and now we're going to talk about frequency. Any questions? All right. So here's, what does it say on this slide? It says D is negative 6. See, small d. Using D. Okay, and then here's finding omega. And then once we found A and omega, we could write the equation. All right, and the frequency of an object in simple harmonic motion. The frequency is the reciprocal of the period. It's just, so frequency, since period is 2 pi over omega, frequency is omega over 2 pi. Just flip it. And so the slideshow shows that frequency is 1 over period, the period. So we flip a fraction to find the reciprocal. That's the reciprocal. And it describes the number of complete cycles per unit time. So that's frequency. It's 1 over period. We just flip the equation for period. And so here's another example. That's it. An object, the last example. An object moves a simple harmonic motion described by d is 12 cosine of pi over 4 times t. T is measured in seconds and d in centimeters. Find the maximum displacement, frequency, and the time required for one cycle. That's the period. Time required for one cycle is the period. So, what's the maximum displacement? The amplitude. That's the amplitude. Is the absolute value of A, is the absolute value of 12. And that's in centimeters. The frequency is omega over 2 pi. You have omega in this is pi over 4. A is 12, so frequency is pi over 4 times 1 over 2 pi. Okay, did you follow why I did that? I just wrote this as omega times 1 over 2 pi. Since omega was a fraction, I wanted to write, instead of omega over 2 pi, I wrote omega times 1 over 2 pi. Then cancel out the pi's, and you get 1/8. And that's cycles per second. The period is 8 seconds, because the period is 1 over the frequency. 8. Or if we found the period first, then we take the frequency is 1 over 8. Whichever one you find first, you can take the reciprocal. These two are reciprocals of each other. And that's section 4A. So we can do the worksheet that's due next time.
Yeah, let's do that.
Yeah. You guys all go around and help you.
I have a quick question real quick.
Sure.
I've had some trouble on MATLAB. How do you, it might be a silly question, how do you identify period just by looking at a graph instead of like doing it the other way around?
Oh, a period is one complete cycle. The time required for one cycle is the period. So if you're looking at a graph, the sine function or something, look at one period and subtract and find the time.
Gotcha. Okay.
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 All right, so we can do that. Work on, maybe we'll work on 4, 7, and 8 worksheet.